Hey, it's Alex Williams of the New Stack. Welcome to the New Stack Makers, a podcast where we talk about application development, deployment, and management at scale. The KubeCon plus CloudNativeCon conferences gather adopters and technologists to further the education and advancement of cloud-native computing. The vendor-neutral event features domain experts and key maintainers behind popular projects like Kubernetes, Prometheus, Envoy, Core DNS, Containerd, and more. All right, here we are for really day one at KubeCon San Diego. We are discussing today the intersection of a new world, I think, the telecom users out there, and how that's really starting to play a part in how we think of not just telecom as telecom as kind of a category, but I think even down to the phones themselves and how people use them every day, but how there's such a complexity underneath that. And so I'm joined by Heather Kirksey, Vice President of Community and Ecosystem at LF Networking. Hey, Heather.
Hi.
And Taylor Carpenter, who's partner and founder of Vulk Cooperative.
Hi.
Thanks for joining us. And Taylor, you're leading the Telecom User Group, which is a new group inside the LF. Is that right?
Within CNCF.
Within
which
CNCF.
Is part of LF. Yeah.
So
I'm co-leading that with Cheryl Hung and Dan Kahn.
Okay, great. And so what I would like to do is look at OPNFV, and we can talk about what is OPNFV, and then looking at it in terms of its mission and how it fits with this new telecom user group, which is acronym TUG. So perhaps we could just start with OPNFV. What is OPNFV for people who may not know a lot about it?
So OPNFV is one of the set of networking projects that we have in the Linux Foundation. Like CNCF, we're part of, which is an umbrella of a number of different projects. LF Networking is an umbrella of projects that are focused on networking and oftentimes telecom. And so OPNFV was started about 5 years ago.
And it stands for, NFV stands for Network Functions
Virtualization.
Right.
Non-telecom people would call it cloud.
Yeah.
But we started about 5 years ago as the operators were really trying to shift from these monolithically integrated hardware appliances where the software was just there, they were single-purpose appliances, to start really kind of taking in some of the virtualization technologies and cloud technologies that IT and enterprise and folks like that were using. To actually and start using those to build their network services and their network offerings, as well as rethinking kind of their back office and their back end as well. And so we've got a set of projects. OPNFV focuses on integration, testing, CI/CD, automation, and compliance activities for sort of the ecosystem and for the networking projects. And then we've got ONAP, which is looking at sort of reimagining orchestration and the back office of telecom. We've got FIDO, which is an accelerated data plane. We've got SDN project, software defined networking in Open Daylight and Texan Fabric. And we've got and a handful of other projects under that umbrella as well.
Interesting. And
a lot of tooling.
Yes, lots of tooling. We've been doing kind of really large-scale integrated CI/CD for years now, which a lot of people might think telecom, they're not cutting edge, but we've been doing like really serious CI/CD within OPNFV for 5 years now. So
A lot of the tools are used in other projects. That FIDO has the VPP, fast data plane, and that's used in many other projects. Within CNCF, within LFN, and outside.
So there's a core community there.
Yeah.
And so what is TUG and why was it started?
TUG is a telecom user group. It's an end-user community, and the idea was operators would be end users, which wasn't really a defined concept within CNCF, but they would be the end users, and then because vendors that are creating telecom software they have a very close relationship with the end users. They're part of that, and the idea is to get operators to be able to voice their problem statement. What are they trying to solve, and then how does that fit in with new innovative cloud-native technologies that are coming out, and being able to get that feedback loop to the cloud-native communities, so that that's part of the new development, and stuff can start meeting the telecom needs.
So, in thinking about both the OPNFV group and your group, and Taylor, you wrote a white paper that I looked at, and I'm curious if you could tell us a little bit about it and what were some of your learnings from it. And then I think that might provide maybe some context for how that learning then intersects kind of with what you're doing, because you have been kind of forging this path for a while, and the telecom user group is relatively new, but the white paper seemed to be your effort to help define it a little bit better.
Within the telecom user group itself, there's been quite a few efforts for white papers and reference documents. You're probably referring to maybe the
Cloud native one.
Yeah, the newest iteration, I would say, within those. So they're all publicly available, and the focus has been trying to get one out that we can start as the main basis that's understandable for operators. So this is kind of chapter 1, and it's a culmination work. It's a collaborative effort with a lot of different people. So I'm not the only author at all.
Right. Yeah.
But they're a collaborative effort. We actually built 5 papers before this. One of my Vulk Cooperative's founding members, Watson, and I have been working with operators and vendors and trying to get a lot of feedback. And then we've gone in and dug into existing books and white papers that are well cited, and those papers themselves, those 5 papers that I'm referring to, they go into cloud native principles and why they're there. So this cloud native is about technologies, principles, processes that have been happening for 20 years. DevOps community, a lot of that's rolled right in. So what do those mean, and then how could they apply into networking? So a lot of the effort in this paper is saying, what are these principles mean, and then how would we actually apply them to platforms? So this would be like newer versions, collaboration with OPNFV, saying as it's going forward, what do we know from the CI/CD and the cloud native side with these practices that coincide?
So when you're thinking about this, Heather, and like the work that they're doing, one of the concepts I've been trying to think about is, this idea of the, cloud native architectures and how they fit with telcos. And NFV has changed a lot in itself. And now you talk about OpenNFV.
Yeah.
And so I'm curious about this idea of cloud native network functions.
Right.
And how that fits with, telcos and to create that cloud native telco, so to speak.
Yeah, and so that's definitely a big area right now. One of the things we have going on in OPNFV at the moment is we've partnered with the GSMA. So if folks don't know that, it's the very large mobile operator sort of trade organization. They put on Mobile World Congress every year. And what we're trying to do with them is we're creating some reference architectures for telecom operators to get some consistency sort of in their deployments as we're continuing the NFV journey. And where we've gotten the first reference architecture out, which is a VM and OpenStack based one, and we are beginning to start our work on a cloud native, basically, reference architecture. And so that is basically sort of kicking off around now. We're also thinking about what does compliance and verification look like for CNFs. And there's definitely there are some paradigm shifts in how you think about applications and how you think about infrastructure, even from kind of where we started with NFV. And so we're trying to really wrap our heads around that, so that we are taking in kind of some of the best practices and the knowledge of what the hyperscalers and what the enterprises have learned as they've done more cloud native, so that when we're using these to build our network services, we can benefit from their experience, but also make sure that we're meeting telecom needs around regulatory requirements and availability and things like that. So it's really exciting, quite frankly, to kind of see basically the sort of like all this innovation and kind of telecom networking coming together.
Yeah, and at the core of what I think of as in cloud native, I think about the past 5 years or so, and how we have moved almost from like cloud services being infrastructure as a service now to something far more based upon dependencies that really then provide ways for developers and people in DevOps to build application architectures, these new technology stacks that are based upon lots of different services and lots of different capabilities. How do you think about that in terms of your own reference architectures that you're building respectively? Because I know that because the Telco user group is building its own reference architecture and OPNFV is building its own reference architecture. I'm curious about how you think about that in terms of how you evolve these different practices into providing kind of a way for people to understand how to think about these concepts.
Right. Well, I mean, I guess the thing is...
It's really two efforts.
Yeah.
From my perspective, it's been that you have, if you look at adoption, there's people that are more risk averse and then folks that are willing to take some risk, and that's depending on their business model. So you need to be able to meet both of those, and I think a lot of the work with CNTT, which I don't think we've mentioned, and get back to that, as part of the reference architecture that Heather was mentioning, it's looking at taking direct input from all the operators that are driving that and making sure that they can meet their current needs. And I think when you feel safe about your current needs, then you're willing to try out new things. And that's part of like the reference architecture number 2. And we had a joint, our first joint meeting between the Telecom User Group and the Common NFVI Telecom Task Force, CNTT, on Monday. We're going to have another one on Wednesday, where we're trying to see where there's common ground directly to potentially work on stuff. There's other things where it's trying to get feedback, which might be, here's some concerns we have with maybe some existing technology that looks close on the cloud native, but has gaps. And so, okay, we need to drive it on that side. And then guidance on maybe what reference architecture too. So there's a lot going back and forth. And from the Telecom User Group side, it doesn't directly write software. It's more about specifications and discussions for like what are these principles, which is part of a process that the CNTT has as well. The part development within CNCF is on the CNF testbed, so the Cloud Native Network Function testbed, and that is trying to build a repeatable development environment and test environment for exploring cloud native technologies. It's not, it would be more like if you read something that talked about benefits and adoption capabilities, and then you said, here's an area that you can try a lot of different things. The reference architecture is actually saying, here is one that's a more complete solution. You're going to have vendors that are going to build out their own, but this gives a fuller idea. So those are kind of both ends of the spectrum from my view on innovating strongly and then making sure you can fit with some existing standards.
What are some of the upstream projects then you've used then to build out the OpenNFV?
Yeah. So I mean, so when we started, obviously we were kind of more on kind of the VM-centric track, and we started doing a little bit of proof of concepting around cloud native, about 2 years ago, I want to say. And actually, tomorrow at the keynote, we are actually doing a proof of concept demo of a prototype 5G network that we've built. And in theory, we are going to do a live video call to southern France. And so some of the technologies that we use to build that, Kubernetes, Prometheus, Fleur kind of that set of CNCF stuff. Also, we've been working with an open source project called the Open Air Interface that does open source radio for 5G and 4G. There were vendors who've kind of come in with their applications that are also running on Kubernetes, so they're cloud native. We've got some OpenStack pieces there that are integrated with that, because I think that a lot of the operators they have a large investment there, and there's
hybrid setup.
Yeah, hybrid setup, and it's also hybrid because there's a couple private clouds that we've got, and then we also are using some public cloud infrastructure. So we've got on stage basically sort of like an edge pop, what you might find in sort of a smaller SIA central office. And then we have what we call the packet core, and that's the sort of like core functions of a mobile network. And that is in a private cloud in Montreal. Then we've got what we call IMS core, and that's a lot of the subscriber and sort of media functions, so passing calls and sort of getting the call signaling or media sessions signaling set up, and then we're calling into southern France where they've got sort of a local pop. So
this is the architecture you built?
Yeah, and so I mean it's a prototype. So it's not necessarily something that's mainline OPNFV release. This was more a bunch of people were sort of like, wouldn't it be interesting if we could see if we could actually, try to build this out on, using Kubernetes and other cloud native capabilities.
How would some of the technologies fit together?
Yeah.
So did you build it out as a software application then, or how did
a set of software applications.
Yeah, right.
Yeah.
And so then you did that. Were you involved in this?
Not specifically. I mean, we've had conversations at Open Network Summit and stuff about where it was going.
Mm-hmm. And why would you do this?
Well, for one thing, really just to sort of prove out that you could build a mobile network, using Kubernetes.
Using open source components.
Yeah, using open source cloud native components.
Mm-hmm.
To really kind of see what was possible. Yeah. Also to sort of explore, what are some of the gaps in various areas. It's a thing that we talk about a lot, but sort of networking within the cloud native world is probably one of the areas that needs more maturing. And so it was to see, okay, what is challenging around networking when trying to build out something like a mobile network, and to have a little bit more, instead of, it looks as though there are gaps, but to actually sort of prove it out by trying, so that you have more specific, concrete feedback. Really kind of start sort of the conversation with something, that we actually, let's roll up our sleeves and try and experiment and see what works, sort of like doing through code. And
specifications, I think, can only go so far. At some point you'll put it together and you realize we missed that.
Yeah, I was going to say, I used to do standardization, and so it's like always when you got to implementation, you realize, no matter how much you tried to think of everything, it's only when it starts getting coded up that you find the interoperability issues, you find the sort of gaps, that you find what's challenging. And so this was an attempt to do a prototype, and we want to take some of that learning from this into some of the reference architecture work, feed it into Telecom User Group, and upstream into some of the CNCF projects. And but also give operators sort of we were able to do this, so if someone is feeling more risk averse, they can see, okay, you are finding gaps, but you can do some kind of basic mobile sort of 5G networking using these open source cloud native components.
So you could be this would directly affect the end users who you work with. I mean,
for sure,
they definitely have an interest, I expect, in 5G just generally. It seems to be on top of the mind of the telcos.
It's literally one of the on the roadmap for the CNF testbed was a 5G. We're looking at Open Air, so we'll be.
What's Open Air then?
Open Air Interface. They're an open source group in southern France. They sort of came from that sort of, Etsy kind of, there's a, strangely enough, there's a large concentration of telecom innovation outside of Antibes in a town called Sophia Antipolis in southern France.
Yeah, there is, isn't there?
Yeah, and so...
what is the roots of that?
It's where they decided to place the headquarters of Etsy, which is the European telecommunications sort of standardization and somewhat regulatory body.
So there's a lot of...
And so once that went there, other things sort of, kind of grew up around it.
France is known for telecom.
Yeah,
if you
yeah.
look
I
at
mean,
history
around,
on that.
going back to like Alcatel, was one of the earliest telecom equipment vendors and things like that. But Orange is certainly cutting edge, and that they've been an operator who's been very involved from the beginning with CI/CD and test automation and framework tooling and things like that. And I lost my train of thought, but anyway, so they're
open air interface.
Yeah, open air interface. So they're an open source consortium that's been working on open source radio, software defined radio for mobile.
So how do you actually
years.
talk to the devices? 'Cause there's a lot of emulators and software out there that can do a large portion of it, but when you get down specifically on telecom, at some point you're going to have to hit the devices.
Physics will come into play.
So that's one area where we're looking at using open air interface, so we'll probably be looking at what they've done for this demo, and we're specifically looking at taking that and integrating it with some other cloud native technology. Network service mesh would be one of the new ones. It's a sandbox project, and looking at building network services in a different way. So how would that look if you're creating something like this 5G use case and setup in a different way? Probably a bit smaller demo, and I don't think I'm going to do a live call. But yeah, definitely sharing of ideas. We've been using other tools like NFV Bench, which is a benchmark testing tool from OPNFV, and many others, and we have folks that are engaged both in the telecom user group as well as specific initiatives like the CNF testbed and other projects that are also within OPNFV and those industries. So.
It's really fascinating work, because what we're seeing is essentially, the abstraction of more hardware and the use of software to solve complex problems that we've traditionally used very heavy equipment to solve, and which is very costly and requires its own specialization. But the telcos have led the way on that specialization, and they've led the way in that innovation. So where does that leave them with the software?
Yeah. Well, I mean, so I recently spent an entire weekend like deep diving into some of the old Bell system, like archive videos on YouTube, which if you are a telecom geek, there's some really awesome ones out there. But you can actually sort of see that evolution kind of going through that. I mean, you see, old videos of, switchboard operators physically making connections. And there was a really cool video with the very first electronically switched central office. And so, I mean, that evolution, from, more mechanical, more physical things to abstracted to software, and we've been moving that way as an industry for a long time. It's just that the pace of that has accelerated pretty extraordinarily. Which sometimes that's a little challenging because it is this accelerating pace. But the nice thing is that, instead of relying on something like Bell Labs for to create all the innovation, we're able to work with folks in other industries, other verticals, to actually sort of collaborate on something like Kubernetes, Network Service Mesh, Envoy together. And so
a data plane VPP.
Yeah, a data plane VPP.
Being open source.
Yeah, so that we're actually able to sort of innovate with other partners and actually be able to take advantage of software written by other folks, sort of be able to take in innovation from other quarters instead of it having to just originate, from our own R&D.
And even on the hardware vendor side, telco specific or otherwise, they're not doing them standalone. They're built for connecting with some software. And the telco devices that you would buy, and it would have all this different functionality, for the last 20 years has primarily moved over to software inside, and it's doing a lot of services. And more, like in the last 5 years, you may have something that appears to be a lot of different components, but they'll ship it as a box or maybe a set of them, and it's a lot of different software working together. And the main idea, I think, with the efforts that OPNFV have been doing the last 5 years, and especially the last couple of years, and what CNCF is doing is saying, let's make all of those pieces have well-defined interfaces and make it where different people can work on them and we can put them together easier.
So when you're having these conversations here at KubeCon and you're talking about these things, what are like the different viewpoints that you hear? And what are those different viewpoints you hear, and like how are you trying to reach these commonalities? What are those commonalities you're trying to reach?
I mean, I would say certainly coming, what I hear from kind of telecom industry is that we need to get, more sophisticated and more mature kind of networking capabilities in
Like in what way?
So the ability, for a lot of the kind of, enterprise use cases, it's pretty basic in terms of the types of kind of network services. But if you start looking at something like 5G, the networking is far more complex, and it's the global mobile network, and so there's folks have VLANs to their corporate environment. You have certain quality of service requirements around streaming. And so being able to do that, which we've always done in our networks with cloud native. You mentioned network service mesh. I think that's a really interesting area where it's looking at, okay, if we have to wire these sort of more complex networks, but we don't want applications to have to be aware of that, but we want to give them capabilities. It's an interesting project.
So that would be like almost like a proxy on top of the network, wouldn't it? And then you'd then allow then the different providers to work on that, to work according to the APIs that are part of.
So that's kind of what network service mesh. There's a lot of efforts to try to extend. I think that the idea with Kubernetes specifically is if you want something other than what you get as the first building block, then you can do add-ons, and there's a lot to extend the functionality, and there's a lot of efforts to do that. The base networking is trying to solve the vast majority of needs and make it really easy for communication. As far as performance and stuff like that, it's general performance improvements. And then when you get into specific industries, trading would be another one, but telecom industry, they can have very specific requirements based on the type of data and information that's transferred and the protocols, if we go down to that. And when you're on a general network, the performance can drop. And what we're really talking about is quality of service, and then you have beyond that the cost. Because you could say we keep throwing money and have more and more machines, but eventually that's what we're talking about. So stuff like network service mesh and DANM and Multis and other projects that are trying to extend the network capabilities, you have the simple one, or you can say we want more control, which is the idea potentially for a telecom operator. This service needs to go over a specific channel, and we need to control how that's going to go. We've purchased maybe specific devices along this path to ensure the quality is high.
So I mean, for example, there's a lot of in telecom, and we have moved far more to general purpose computing, but for certain things, like stuff that really is latency dependent or requires high bandwidth, a lot of folks are using various types of hardware acceleration, and so figuring out how to offer that in sort of a standard way so that people aren't having to code applications to specific NICs or specific, FPGAs or whatever, like we want the interoperability.
That's a converged hardware.
Yeah, we want the interoperability. We want the ability to migrate workloads to different places. That is sort of the cloud native promise. But there are certain areas where we do require some specialized hardware capability to make sure that performance is happening.
Where can people learn more about OPNFV and the Telecom User Group? Is it good to go through, LF networking and that way? And how can they get involved? Who are you looking for?
Yeah. So, I think we are looking for, first of all, some folks with cloud native expertise who can help us kind of define some of these reference architectures, because we have a lot of telecom expertise, but we're building our cloud native expertise. And it's kind of, really exciting if you really think that Kubernetes could be used for
building
the global communications infrastructure. It's interesting, hard problems at huge scale.
Yeah.
I think it's the sort of thing that is exciting from an engineering perspective.
Yeah.
But so places to go to look. So probably the LF networking wiki is one good place, because it will direct you to different projects like OPNFV or this joint task force that we have going with GSMA, where we're defining the cloud native reference architecture.
You can get to that off the main Elephant website, the wiki.
Yeah, and so and it can kind of direct you. I think right now, participation in both our sort of what we're calling OVP, that's our compliance and verification program. We've started a phase 2 that's focused on cloud native, or sort of the CNTT reference architecture work, the cloud native reference architecture work is where I think we're really looking for some folks to get involved in right now. And then I know
CNTT has wikis off the OPNFV, and both OPNFV and all of the sub-projects, there's a OPNFV Slack for if people wanted to do live chats. The Telecom User Group is on the CNCF Slack, so if people join that, they can get involved with TUG directly, the CNF testbed, Prometheus was mentioned, Network Service Mesh, all those projects for chat. Both the Telecom User Group and these projects, OPNFV, they're all on GitHub or some other public source repository.
Yeah, and I was going to say, we have a developer event coming up in January in Prague, where you can find the registration information off of that main LF networking wiki.
Has a new name, doesn't it?
It's the LF Networking Developer and Testing Forum, and so we're actually going to be doing some live testing of VNFs. CNTT and OPNFV are going to be there. ONAP's going to be there, and it's a focused kind of developer, architecture discussion, specification discussion, and actually sort of live hacking on some of the code. And
so CNF testbed may be on that live the hacking track.
Awesome.
So,
Well, sounds like fun, and sounds like you guys are really busy. Some very exciting stuff. The thoughts of building 5G networks just in a prototype for Kubernetes is, a project in itself that I think shows for you all the opportunities, but also the real gaps, as you say, in networking, and this whole kind of move toward thinking through how you build out these architectures using really basically the compute, storage, and networking that is available out there, and building the applications for it is a fascinating topic. So thank you very much. I've been joined by Heather Kirksey, Vice President of Community Ecosystem for LF Networking, and Taylor Carpenter, partner and founder of Vulk Cooperative and key member of the Telecom User Group of the CNCF testbed. So thank you very much.
Thank you.
The KubeCon plus CloudNativeCon conferences gather adopters and technologists to further the education and advancement of cloud-native computing. The vendor-neutral event features domain experts and key maintainers behind popular projects like Kubernetes, Prometheus, Envoy, Core DNS, Containerd, and more. Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.